Hi there and welcome to this lesson. I'm quite excited to explain a new method that I finally worked out for myself to do trinomials where the a value is actually not equal to 1. Not equal to 1. In other words, we have this format. We have a trinomial, that's a three-termed expression, ax squared plus bx plus c, where this a value is not equal to 1, and then what we're trying to do is to factorize it into two brackets. Now the method I know and I used to learn from school is called the cross method, and it's this massive intense formula, not method, that really always confused me, and I think it's a complete waste of time. But what I want to show you is a way of doing it using formulas. Now I am not keen on teaching formulas, and definitely I don't like teaching methods, but for this type of work I really think it's helpful, and it just saves a lot of time for something that can be very tedious in a long method. Okay, so I'm going to explain where I get the method from in this video. If you don't understand completing the square, then this method or the explanation won't necessarily make sense to you, and you might not know what I'm doing, and in that case I suggest you just skip it and just follow the method that I suggest. But if you're like me and you want to know why this method works, then spend some time analyzing each step I do. You will understand it if you make an effort, and you'll see it's really brilliant actually. Now let's get started. So what I'm going to do first is called completing the square. Now to complete the square for this expression, I'll first take out an a as a common factor from the first two terms. Now it isn't a common factor in the second term, so what we'll have to do is divide the b with an a. Okay, so basically what I'm doing is I'm giving it an a, but since I'm giving it an a, I must also take it away by dividing with it. So if I take out an a as a common factor, I'm left with the b over a factor, b over a x. I'm just going to do that for the first two terms, and then the c is still there. Now the aim of completing the square is actually to try and get an expression that can factorize into two brackets, and those two brackets are exactly the same, so it is a square. That's why it's called completing the square. In the next step, what we do is a very typical step that we always do in completing the square is to take the factor in front of the x, and it's not 2, it's an a, okay, to halve it and square it. So I take this term, and then in this bracket I'm adding another term. I'm going to add half of this term, which is b over 2a, okay, and I'm going to square it. Now I'm not allowed to just add things the way I wanted. I can't just add a number to another number. It changes that number. So if I wanted to add it, I'll also have to subtract it. In a similar way, where I gave an a factor here, I multiplied with an a, then I must also divide with an a. That's allowed because I'm not really changing the value, I'm just changing the expression. And that's what I'm doing here. What I'm doing is I'm also going to subtract b over 2a squared. Okay, but notice that this term that I added was added inside a bracket that's already being multiplied with a. So if I subtract it, I must also just remember to multiply with an a. Okay, so because it's in a bracket, this a, if it gets distributed, this one's going to get an a. So the thing that I'm subtracting, since it's not in the bracket, it also deserves its a. So I must just remember to add that as well. Okay, hopefully you're with me so far. In the next step, I'm not going to explain too much about this, but basically this can separate into two brackets or factorize into two brackets. And the two brackets will be exactly the same. The brackets are x plus b over 2a, because the question is, what can I multiply with it? What can I multiply to get b over 2a squared? And when I add them, I get b over a. So b over 2a times b. Oh, let me write it a bit further apart. B over 2a times b over 2a When I multiply them, I get the b over 2a squared. When I add them, I get b plus b. I add numerators. I get 2b over 2a, that's b over a. In other words, I get the middle term. So in other words, the two brackets is a x plus b over 2a, x plus b over 2a, so it's x plus b over 2a squared. Then on this side, since I'm just going to simplify this a little bit, and I forgot my c, I apologize, there should be a c in there. So we have plus c plus or minus, and then this thing, when it simplifies, becomes b squared over 4a squared. But remember, we still have to multiply with that a out there, and that a will cancel with one of these a's, so we have b squared over 4a. Now from here we can go ahead and just simplify or add these two numbers together, and the reason why I'm going to do that you'll understand in just a minute. So I'm going to have this term, that's an x plus b over 2a squared, plus, and then when I add these two together, this one is over 1, so I need to make it over 4a. To make it over 4a, I'll need to multiply 4a in the numerator and denominator. So we get this expression, 4ac, and in the numerator I get plus 4ac minus b squared over 4a. Okay, now one more thing that I want to do is I want to make this expression the difference of two squares. So I want, here I already have a square, it's not the difference of two squares because of the a, and I'll deal with that in just a minute, but in order for this to be the difference of two squares, I need that to be a negative. I can get that to be a negative by just swapping these two terms around. It's like having 2 minus 1 is equal to 1. If I swap it around, I get minus 1. So I can change the sign in front by just swapping terms that are being subtracted from each other. So that's what I have. I'm going to keep the color x plus b over 2a. And I'm sure you can see now this is a complicated, very complicated proof for my method. But some of you might be familiar with it because we are slowly reaching a formula that in some of the higher grades you use so much that you might as well make an effort to know this proof now, because you will encounter it a little bit later on. Okay, I did that, sorry, I don't know why I put a 2 there, that should be a 4a. Okay, nothing changed there. What I want to do now is, in order to have it the difference of two squares, I need to get rid of this a. So what I'm going to do is take a out as a common factor. So I'm just going to, again, we don't have a as a factor here. We have 1 over a as a factor, but that's not what I want to take out. So I'm going to give it an a in the numerator, and I'm going to give it an a in the denominator, so that I can take a out as a common factor. So I take it out as a common factor, and I'm left with x plus b over 2a squared minus, and on this side I took it out, so I'm now left with b squared minus 4ac divided by 4a squared. Okay, and this is now going to be the difference of two squares. Again, we see, but this is not really a square. It's almost, if it wasn't for this minus 4ac, it would have been a square. But I'm going to separate this into two brackets. So I've got an a here, and then I'm going to break this into two brackets, a bracket here and a bracket there. The difference of two squares, when you take the difference of two squares like x squared minus y squared, it breaks up into two terms, an x plus y and an x minus y. That's the idea. But you can see basically what we do is we take the square root of the first value plus the square root of the second value, and in the next bracket the square root of the first minus the square root of the second. So that's what I'm going to do here. If I take the square root here, I'm just left with x plus b over 2a. The square root of the second, I can take the square root of the whole thing, and I can break up the square root as the square root of the top and the square root of the bottom. So I've got minus the square root of b squared minus 4ac. And at this point, a lot of you that actually know this formula might be familiar with this b squared minus the square root of b squared minus 4ac. And then here in the denominator, I took the square root of the top. The square root of the bottom is 2a. Okay, that one I can't take the square root of. This one we could, please do remember, we can't break this up into square root like that. That's not allowed. We can't separate exponents. This is actually a bracket exponent, a half, if you didn't know. But we can't separate that over terms. In the next bracket, I'm doing exactly the same. I've got the square root of the top, the square root of the first term, which is just cancelling with a 2. Also something you might learn in a little bit of the higher grades. If you don't understand that yet, then ignore this and just wait for the method. And then what we do is, here we use the negative. And we want one bracket to have a negative, one to have a positive. So this we can put as a positive. Doesn't matter which one you do first, of course. But then again, we have b squared minus 4ac, sorry for that, over 2a. Okay, so there we have our two brackets. Now you'll remember that what I've wanted to do from the beginning is I want a method to factorize this thing into two brackets. And actually I've done that. I have actually done that. There's my factorization into two brackets. The problem is with this thing is that my two brackets has just an x, and the other two terms unfortunately are fractions. Now we want to factorize it actually into a form that looks something like this. So an x and an x, then we want a coefficient here, let's call it s, and a coefficient here, let's call it t, and then to get this c, we'll have to multiply these last two terms, so let's call them u and v. Okay, but notice that if a, b, and c are are numbers, are whole numbers, then we expect u and v also to be whole numbers. So u times v must give me c. So we expect it to be whole numbers, and at this point, this would be u, and that would be v, and the coefficients here will only be 1 and 1, and then when I multiply in the a, obviously, so I'm going to multiply x times x, get the x squared, and then multiply in the a to eventually get that a coefficient. But that's not what I want to. I actually want a coefficient for x, and either one or both, it depends. Different questions simplify differently. But if we go ahead now and take 2a out as a common factor, not 2a, in fact, we take 1 over 2a out as a common factor. Now again, this first term doesn't have a 1 over 2a as a common factor, so what we will do is we will give it to him. But once again, then I must also give it to the numerator. But if I take out the denominators 1 over 2a, I'm actually taking out a fraction. So I've got the a so long. I take out a 2a out of this one, a 1 over 2a out of this one as a common factor, but also I take it out of the second bracket as well. So I'm going to take it out of the first one and then be left with 2ax. Remember, I had to give the 2a now, plus, and now this one doesn't have the 2a denominator anymore, so it's just b minus the square root of b squared minus 4ac. And then this one is also, I'm going to do it on this side. But the moment I take out a 1 over 2a as a common factor from this bracket as well, then I've actually taken it out twice. Okay, if you take it out of the one bracket, that's fine, you would just have it. But now we take it out of a second bracket, so now we've taken it out twice. So we have done this twice. That's why there's a square there. Okay, and I'm left with basically exactly the same. The only difference is that instead of a negative in front of that square root, there's a positive. So very simple. So far it looks complicated, but again, people from the higher grades actually recognize these variables. They're quite common. What I do want to show you though is that this just simplifies. I'm going to simplify that, and that becomes there's two a's in the denominator. One of them will cancel, so in the top I've got 1 over 2 must be squared, so that's 4a 1a left because the other one cancelled, and then I've got 2ax plus b minus square root of b squared minus 4ac, and then 2ax plus b plus square root of b squared minus 4ac. There you go. There is a formula to factorize this expression up here into two brackets that look like that. We've got a coefficient for the x plus a constant, coefficient for the other x plus a constant, and that's exactly what we have here. The only problem is we don't really want any sort of fraction in front. That wasn't part of the deal. So you'll notice what you'll have to do after you've done this question. So you'll use this formula, apply it to the expression, but then you'll always notice that if it's possible to factorize this thing into two brackets, if it is possible, there's going to be two things needful. One is we have the square root of a number here, and we want this whole thing to be a whole number. For this whole thing to be a whole number, the square root has to work out perfectly. In other words, what's in here must be a perfect square. What's a perfect square? Well, it's a number like 1 or 4 or 9 or 16, something you can take the square root of, and so we'll get a nice number in here. B is just whatever's in front of the x. I'll do a few examples and you'll see how very simple this actually becomes. Okay, so that's the first thing. We need this b squared minus 4ac to be a perfect square. 1, 4, 9, 16, so then 25, that's 36, etc., etc. The next thing we need is that after we've actually substituted it, we must be able to take out a 4 as a common factor, and we can do that either by taking out a 4 from each of the terms in one of the brackets. So there's something like 4x plus 8, then we can take out a 4, or we must do it by taking out a 2 from the one bracket and a 2 from the other bracket. So we've taken out a 2 again, so we've taken out. Now when we take out common factors like a 4, we'll have a 4 in the front. Then you'll also always be able to take out a as a common factor. Whatever is in front of, because you can see here, if I multiply these two terms, I'm going to have 4a squared x squared, and we can see we have too many. That should just be a x squared. So somehow we must be able to take out a 4a from this, from one of these two, but not just from any one, from the one where we can also, so we're going to take out as a common factor from the first term and the second term, but we'll only be able to do that once. Okay, so at this point it might seem a little bit, what on earth are you doing? I have no idea, I'm so confused, and all I'll say to you now is, if you want to use this method, you will basically need to know this formula. It's an intense formula. It won't be on any formula sheet you've ever seen. It's basically just the one bracket that repeats itself, just with a positive in front of the square root, or a different sign in front of the square roots. And so it's not that intense, but you'll have to know that. But as soon as I start doing a few examples, you'll see, based on the cross method, that the only other method I know, this is way simpler. And as a matter of fact, later on in higher grade, you're going to learn a formula called the quadratic formula, and you'll also see how that relates to this question, and even how we use that quadratic formula to determine whether an expression like this can actually factorize. We can already do it now. We can already understand it now by understanding it can only factorize if b squared minus 4ac turns out to be a perfect square. But in the next video, I'll do a few examples using this method, and you'll see it's lovely. It's very easy to use. See you there.